Hey guys, Dago here. There's a couple things in class that, some parts of the formula that I know people got a bit confused on. I heard a bit about the value, and Miss mentioned one thing offhandedly to me while we were solving it that I realized would be very important for everyone else to know. So let's get into it, right? First of all, here's how I break it down, right? We have 8 points of data here, right? And a quarter is going to be 1/4 of that, so a quarter is going to be 2. So since we have 8, little rows or points of data, we're going to get these 2 rows, and this is going to be our Q1, right? Because this is our first quarter. Then we're going to get the second row, and that's going to be our median, or Q2, and then the third row is going to be our Q3, right? Because that's what we need in order to make the box and whisker plot that the question initially asks us. Which, just to quickly mention, um, the reason this minimum and maximum are important is not anything related to solving for these or this. It's for the box and whisker plot that it actually wants you to make. Because the minimum is going to be 25, which we didn't know previously. The maximum is 370, and naturally with this formula, we're going to be able to solve for the median Q3 and Q1, right? So here's how I want to explain, right? The lower boundary is going to be one of these first values in this Q1 space, right? For a because that's what we have to value. All right, sorry. The value that we're solving for is Q1, right? We need Q1 of this box and whisker plots. So to solve that, we need to get the lower value of the first quarter of our data. Well, what's the lower boundary, right? It's going to be one of these two. Well, how do we know which one to use? Well, we're going to be using the smallest or the first possible one, but it has to meet the quartile position. For example, in Q1, the quartile position is 50, which if you remember was from that thing earlier where it was like the total frequency divided by 2 divided by 4 times 3 divided by 7. And the quartile position that we got, for the first one, Q1, is 50. Sorry, yeah, it's 50. So 50 is the quartile position for Q1, right? So we're going to use the earliest one, which the cumulative frequency is at or over 50. And as you notice in this first little point or slot of data, it's only 16. So you're going to move on to the next one, 54, which is, correct, so which is about 50. So we're going to have to use this one here. So our lower boundary here is going to be 50, because, lower boundary. Our quartile position is 50. The cumulative frequency before 54 is 16, and the frequency of a this is 38, with the width being, of course, 50. It goes up 50 or whatever. And once you put all this, you're able to get 95. So that's going to be Q1. And now, following my rule, we're going to go to the median, right? So the lower boundary of our median, we're going to test this first one. Its cumulative frequency has to be 100. And if you come all the way over here, it's 104, which, is at the standard. So we're going to be using this plot. And then you use this for the lower boundary, and that's 100. You use the 100 from the quartile position of the median for here. And you subtract the 54 of the previous cumulative frequency, divided by 50 of the current frequency, which is right here. And, times it by 50, and you get 146. And, you follow the exact same for Q3. Lower boundary 200, K of 150, cumulative frequency before of 140. And, just to reinforce it, 172 does meet the 150 mark. And that's kind of how you find that, right? I really hope I explained that well enough. Please feel free to reach out to me. And thank you very much for your time.